In this video, we're going to take a look at how to multiply and divide rational expressions. Now, before we do that, let's take a look and recall how to multiply rational numbers. So if the numbers are too large for you to multiply without a calculator, it's actually easier to maybe factor, reduce, and then multiply. So let's take a look at a couple of examples. So we have here 5 over 18. 5 is already a prime number, but 18 is not. So I'm going to break 18 down into 2 times 3 times 3. And I also have 14, which can be broken down into 2 times 7. And 15, which can be broken down into 3 times 5. Now, because I'm multiplying here, I can actually just draw one big line and put dots in between to show the multiplication. Okay. And now that I have it broken down to fit factors, I can see what's the same. So I have a 2 on the top and the bottom, and a 5 also. And remember that when we factor and we cancel, these numbers become 1. So in the end, I have 7 left in the numerator, and 3 times 3 times 3, which is 27 in the denominator. Let's look at one more. So again, 6 can be broken down into 2 times 3. 32 is 2 times 2 times 2 times 2 times 2. Now, if you're not sure how to break these down, remember that you can also draw a factor tree, and that will show you the factors of each number. 40 is the same as 2 times 2 times 2 times 5, and 27 is 3 times 3 times 3. Remember, I can draw one line and put a time symbol in between. So we have a lot of factors that are the same here. We got the 2, we have a 3, 3 more 2's, so 3 more 2's get canceled on the bottom. And here in the numerator, we just have 5. In the denominator, we have a 2, a 3, and a 3, which gives us 18. Now, we actually don't really need to obviously break all of these numbers down into their factors when we're multiplying just fractions that are not rational. But what I wanted to show you is that when we factor this, we can see that the factors, what they are, and then we can reduce and cancel. And we're going to do the same thing with rational expressions because we want to write these into factors before we cancel. Notice that in these two questions here, there are no adding and subtracting symbols. Everything is multiplying. And then we can only cancel off the numbers that are being multiplied by each other. So let's take a look at rational expressions. So in this first one here, what I'm going to do is I'm actually going to do it the same way that I just did the rational numbers. And I'm going to break it down into all its factors. So 35 is the same as 3 times, the same as 5 times 7 times x. And then the denominator, I have 2 times x times x times x. And then in the second fraction, I have 4x's. And then my denominator, I have 2 times 7. So remember, I can put a time symbol in between and actually just write one big long line to show I'm multiplying everything together. So notice everything again is separated by the dot or the time symbol. So we have a 7 that's the same on the top and bottom. 1, 2, 3 x's on the top and bottom. Now I can't reduce the 2 2's on the bottom because they're being multiplied on the bottom. So we'd only reduce when there's a common factor on the numerator and the denominator. So this leaves us with 5 times x, which is 5x squared, and 2 times 2, which is 4. Now this is kind of a long way to multiply monomials. So let me show you a faster way to do this. So I'm going to rewrite the question over here. Now, we can actually probably just strictly reduce right away. So I can see that there are 3 x's on the bottom. We have an x cubed, and that can reduce with this x to the 4. So that will reduce the 4 to a power of 1. 35 and 14, I can think of a number 7 that goes into both. So 7 goes into 14 2 times. 7 goes into 35 5 times. So what I have left is the 5 times x, or I can just say 5x over 2, and then times x over 2 to make it a little bit neater. So then I have 5x squared divided by 4. Now, taking a look at the non-permissible values, These are the values we look in the denominator, and we can see that we have only x's here. These are all our single factors. So from here, we know that x equal to 0 is the non-permissible value. All right, let's take a look at a different question. This one worked out that we can do it a couple of different ways because they're monomials. But when they're trinomials or binomials, they're going to look a little bit different. And you'll see that in this question C here, we have minus signs and plus signs that join the terms. So because of that, we cannot actually just cross off the x squared because x squared is not the factor. X squared minus x minus 20 would be one complete factor. So we can't reduce or cancel anything until the factors are separated by our time symbols. So we need to factor each expression. So find two numbers that multiply to negative 20 and adds to negative 1. So that's going to be negative 5 and x plus 4. Do the same thing with the denominator. Find two numbers that multiply to 15 and adds to negative 8. So that's going to be x minus 5 and x minus 3. And we do that with all of these expressions. So we have x minus 3, x plus 2, and we have x plus 4 and x minus 2. So if you're not good at factoring, make sure that you practice, and you can check each of your factoring by multiplying the two binomials back together to make sure that you actually indeed get the trinomial. All right, so now that we've factored, remember we can actually pretend that there are a whole bunch of dots in between, which represent our time symbols. Draw a line here. And then we can only cancel anything that is separated by the dots, that's separated by the time symbols. So we have x minus 5, x minus 3, x plus 4. And the only thing we now have left is x plus 2 divided by x minus 2. All right, looking at the non-permissible values, we see that we have 4 factors. So each factor will produce a non-permissible value. So in the first one, x minus 5 can't equal 0. So x equals 5 is a non-permissible value. We have 3 as a non-permissible value, negative 4, and 2. So if we plug in any of these numbers into the denominator, we would actually have a 0 in the denominator, which would not be permissible, which would not work. All right, so now we're going to take a look at division. And division is very similar to multiplication. The only thing is that before we can actually figure the solution out, we need to take the division sign, change it to multiplication, and then take our second fraction and make it into a reciprocal. So we have to multiply the reciprocal when we divide. Now I'm going to do this the quicker way, just by canceling. So I can see that 3 goes into itself once, 3 goes into 24, 8 times. The 10 goes into itself once, 10 goes into 60, 6 times. So I'm left with 1 times 8 in the numerator and 1 times 6 in the denominator. And this can reduce to 4 over 3. Taking a look at one more, we are going to remember, change division to multiplication of the reciprocal. So again, we can reduce. 8 becomes 2, so 8 divided by 4 is 2. 12 divided by 4 is 3. 5 goes into 10 and 15, so 5 goes into 10 twice. 5 goes into 15 3 times. So again, we can't reduce numbers that are side by side. So we end up with 2 times 2 in the numerator to give us 4. And in the denominator, we have 3 times 3, which is 9. So this procedure here that we've did for division, rational numbers can be applied to rational expressions. So let's take a look at a couple down here. So I'm going to take a look at B. Since we already did a monomial multiplication, let's take a look at a binomial division. So remember the first step, we are going to rewrite the expression, change it to the multiplication of the reciprocal. I can factor this first term. It's actually a difference of squares. So this becomes m minus 5 and m plus 5. In the denominator, I have m minus 4 and m plus 4. Now the second fraction is not a trinomial, is not a difference of squares, but it is a binomial that has a factor that I can take out. So we take a look and we can see that I can factor out a 4. So I have m plus 4 left. In the denominator, I can factor out a 2, and I have m minus 5 left. All right, now unlike the other ones, I'm going to actually find the non-permissible values at this step here to make it clearer. So we got 1, 2, 3 factors. Now there is an extra one that we need to take a look at. So back to my original question, 4m plus 16 was in the denominator, but now it's moved to the numerator. However, because it was in the denominator before, I also need to look at m plus 4 as a non-permissible value. So here we have m equal to 4, negative 4 in the second binomial, and we have 5. And when I look in my numerator, I also have another negative 4 as a non-permissible value, but I've already written it down so I don't have to write it again. Okay, we do some canceling. This is the fun part. And the 4s and 2s I can reduce to 2 over 1. So the only thing I have left in the numerator is my m plus 5. But I also have a 2, which I'll place in the front. In the denominator, I have an m minus 4. All right, let's take a look at one more. So the last one here, again, let's just rewrite the question so that it is multiplication of the reciprocal. And we're going to factor each of our expressions. Difference of squares in the bottom. In this numerator, I can factor out an x and a trinomial, so it's x plus 7 and x plus 1. All right, so let's check for non-permissible values. We have 1, 2, 3, 4. And remember, this used to be the denominator, so we still can't be equal to 0. So we need to check our numerator here. So we have 6 factors that we need to check. So we have x equals 7, negative 7, another negative 7, negative 1. The x on its own actually represents 0. And then we have x plus 7, so negative 7. So we have 4 non-permissible values here. All right, so the fun part, let's cancel. So x minus 7, x plus 7, x plus 1. And the only thing we have left is x divided by x plus 7. Now, just one comment about the 0 here so that we don't forget. So we need to remember to check the numerator of the second fraction. So second fraction really meaning the fraction that was divided, okay? So check for the numerator of the second fraction for non-permissible values. So because it was in the denominator and can't be 0, we still need to check the numerator after we flip the fraction. So now you know how to multiply and divide rational expressions.